All right, ladies and gentlemen, welcome back. This is chapter 2.2. The first of our chapter 2 videos. We're skipping 2.1. In this video, we're going to be finding slope and rate of change. This is a review concept from algebra. Our three major goals for this lesson is that you will be able to calculate the slope given 2 points, whether it be on the graph or just 2 points given. You will be able to classify whether a line rises, falls, or is horizontal or vertical based purely by looking at the slope, not a graph. And you will be able to see if two lines are parallel, perpendicular, or neither based on the slope. So let's talk about the slope. The slope is basically a ratio of its vertical change, which we call the rise, to its horizontal change, which we call the run. To give you a couple of different pictures of this, if we were to talk about it on a graph, first of all, slope only makes sense when we're talking about a linear equation, thus creating a line. We can draw a little triangle here. This vertical distance right here would be the rise. We can also call this, if we were to take two arbitrary points on the y-axis here, we would call this y2 minus y1. This distance is the difference between y2 and y1 here. And then this horizontal distance, again, we can kind of pick 2 points, calling this x1 and this x2. We can calculate this distance by taking x2 minus x1, this point minus this point. And again, we call this the run. The whole idea of slope is it tells us how quickly is a linear equation or something linear, how quickly is it increasing or how quickly is it decreasing, or if it's horizontal or vertical. Okay, so here's a picture of that. We take a ratio, meaning we take the vertical change divided by the horizontal change. And that's our slope. And we denote slope with an M, okay? So this vertical change, the ratio of this change right here to this change right here, which will give us a quantifiable number, which we simply say is our slope, okay? Sometimes you might also see this denoted as like the change, the triangle there, the change of y over the change in x. There's a few ways that that kind of comes up. But this is what the slope is. It's how much is a line increasing or decreasing, and how quickly is it doing that. So let's do a couple of examples here. A skateboard ramp, all right, there's my skateboard ramp, has a rise of 15, oops, and a run of 54. What is its slope? Well, it's 15 over 54 because it's the vertical change divided by the horizontal change, which is 54. Since I know that it goes up 15 and over 54 in inches, this is 15 over 44. We should check to see if this can be reduced at all. So do they share any common factors? 15 is 5. That's not 5. What about 3? Let's see here. That's 5 something. And then, well, let's see. We can anchor it to 60. 57, 54 up. It does go into 3. So this is going to be 5 over, it would be 20, but we went 2 to the left, so that's 18. So 5/18. Right? So my slope here is 5/18. We can also do slope out of context. What is the slope of a line passing through the points -1, 3, and 2, -1? We can see this on a graph if you just want to imagine 2, -1 is right here, and -1, 3 is up here. So what's the difference? What's the slope for that line like this? We can draw that little triangle like we did on the last slide. The other thing we can do is use our formula that we discussed in the last slide, which is taking the vertical change, y2 minus y1, over the horizontal change, x2 over x1, knowing that this would be my y2 and my y1, and this would be my x2 and my x1. So we would call this negative 1 minus 3 over 2 minus negative 1, which gives us negative 4 over 3, negative 4/3. So slope is the ratio of vertical change to horizontal change. You can see that in the couple of examples that we did here. Now, if you can go back to your notes, there's a few problems that I would like you to try on your own. If you are watching this, you can check the next video and see what those problems are and do them for yourself. All right, so we'll see you in the next video in a couple minutes. Bye.